Alright guys, so I decided to go ahead and make a video of what we covered in class today to kind of help you with the questions from the Nearpod. Since we did that in class, we started it, but we didn't have a chance to finish. So I'm going to go ahead and work through questions 1 through 5. That way, if you wanted to refer back to how to solve them, and you need kind of a go-to video if you get stuck, you guys can refer to this video. Okay, so I'm going to start with question 1. Like I said, we did this in class, but I just want to make sure that you guys are good. Okay, so question 1. Again, I'm referring to the Nearpod. If you want to go ahead and open that up, it's on eClass. If you look under content for today, Wednesday the 9th, it's called PercentNearpod. Okay. So number 1 says, in September, 70% of the middle school students participated in donating to PTSA. If there are 1,610 students that donated, how many students are in middle school? Okay, so first step, what I'd like for you to do is go ahead and list out your part whole. Okay, so first step is we're going to see what we're solving for. The last sentence in your question says, how many students are in middle school? Okay, you need to ask yourself, do you think that's a part or a whole? Anytime it's asking for an all or original or how many attempted, total, something that kind of indicates overall, that means you're solving for a whole. So this question's saying how many students are in middle school, meaning we're solving for a whole. Please don't just put an X because that's not going to help you or me. So be specific. X is the total amount of students in middle school. Students, if I can spell. Alright, now we're going to deconstruct the other pieces. Now it says 70% of the middle school students participated in donating. Alright, I know that's a part in the form of a percent. So I'm going to go ahead and write 70% of the students that donated. So these are the students that donated. Okay. Now I'm going to go ahead and add the other section of our word problem. It says 1,610 students that donated. Okay. So that's also a part, and I'll explain why. Because right here we're solving for the whole. So no other number can replace that whole. Meaning this must be our part. Now you're going to know whether or not you're ready to solve when your two parts match. Okay, so if this is telling you the same thing, then you can go ahead and solve for your, or set up your percent proportion. Okay, so 70% donated, 1,610 donated. Okay, these match. So I can go ahead and fill in my information for my percent proportion. Okay, I always know there's a part out of a whole, and I want you to label that. I know it's tedious, but go ahead and do so. And I also know that there is, the percent is always out of 100%. That's just given to you, always. All right, I know that this part is 1,610. It goes here and not here, because this piece of information goes there. You're always going to have a percent over a percent. It's never going to go here or here, okay? These percents stay together because you're saying this fraction is equal to that fraction, okay? And then you're solving for your whole, okay? So again, guys, I told you in class I want you to learn how to scale, and I want you to, and you can check yourself with cross multiplication. So the two given pieces is here, all right? Now, I need to figure out how I got from 70 to 1,610, all right? So I don't know what 70 times whatever number is. I don't know how many times 70 goes there. So I'm going to figure out backward, okay? I'm going to work from 1,610 to 70. Since I'm going to a small number, I have to divide. So if I divide 1,610, I don't know if you guys can see this, if I divide that by 70, it gives me the number 23. Okay, so that means if I divide 1,610 by 23, it should give you 70. So if I use that logic and scale up to 1,610, that means I would multiply by 23. If I use that same logic for my denominator and multiply by 23, I should get x is equal to a total of 2,300 students at NGMS. And I don't think that was part of the question, but that's okay. So again, that's how you do it with scaling. Here's how you do it with cross multiplication, okay? You're gonna take your two numbers that you've got that are across from each other. That's 1,610 and 100. You're gonna multiply those together to get, I believe, 161,000. So 1,610 times 100 gives you 161,000. You're going to divide that by your unused number. I haven't used 70 yet, so that divided by 70 gives you 2,300. So we were right, okay? So let's go to question 2. All right, question 2 says, in Miss Delinsky's class, 40% of the students like the dance move, ride the pony over the worm. How many students like the worm? So again, you're going to start with, let me label this, question 2. You're going to start with part, whole. Okay? Now, I told you the first step is you need to see what the question is asking. Okay? It's asking for how many students like the worm. Is it asking for how many students total or in all? No, it's not. It's asking for a section of a student. So that means we're solving for a part. Okay? So when I put my X here, I'm going to be specific. I'm asking for how many students like the worm. All right. It also gives you two pieces of information additional to that. It says 40% of the 35 students like the dance move, ride the pony. Okay? If that's saying 40% like ride the pony, that means that's my percent that I'm given. 40% like, oops, sorry. I'm going to say the pony. I'm sorry. All right. And then it also says 40% of the 35 students. I remember I told you that of is a key word indicating whole. So of the 35 students in my class. That means that there are 35 students present in my class. That means that must be a total. It's a whole. All right. Now here's the problem. This part, this is 40% that like the pony, and this is X amount of students that like the worm. These two parts don't match. That means we got to get a little creative. And we got to create another part, okay? Because we have to solve for the students that like the worm. I don't really care about the students that like ride the pony. I'm so sorry. I do care about you, but the problem says we need to solve for the ones that like the worm, okay? So we're going to think about it like this. If I know that 40% of the students like ride the pony, that means if I think about it out of 100%, 60% must like the opposite. So 60% like the worm. Okay? So now I've got two parts that match. Again, if I add 60% and 40%, that gives me 100%. That's my whole, okay? I went ahead and just created another piece of information from 40%. Now I can use this part and match it with this 60% because I want to know the kids that like the worm. Okay, so now I can go ahead and set up my percent proportion. Okay, I always know it's a part over the whole, some percent out of 100%. And if I know that I'm solving for a part, I'm going to put an X here. And I'm going to use the 60% because it matches my part. And I have a total of 35 students. Okay? So if I went ahead and scaled up, just like I told you, it's kind of hard to think about what I need to multiply 35 by to get to 100. So I'm going to work backward. I'm going to divide 100 by 35. And if I do that, I should get, you guys can see this, about 2.857. We're going to go 3 decimals, okay? So 35 times, actually let's go backward. So right here, I'm going to have to figure out x, okay? So if I went from 100 to 35, I'm going from a large number to a small number. That means I'm going to have to divide by 2.857. So if I want to check that to see if it gives me 35, I can do 100 divided by 2.857. Does that give me about 35? Yes, it does. Okay, so I'm going to use that same scaling factor, and I'm going to divide 60 by 2.857. And I should get 21.001. So you can just keep 21, we'll leave it at that. So that means x is equal to, there are 21 students that like, oops, sorry, I should have added students that like the worm. Perfect. And you can take that a step further and check yourself with cross multiplication. If I multiply the two numbers that are across from each other, 60 and 35, I should get, and you guys can work along with me, you should get 2100. Okay, then I'm going to divide that number by 100. So 2100 divided by 100 gives you 21. We were correct. Okay, let's move on to question 3. Okay, I'm going to shorten this, Q3. All right, now Q3 is a little bit difficult. Okay, I'm going to go ahead and just show you as a proportion. Okay, because I think that's easiest to think about. So number 3 says the ratio of cats to dogs is 2 to 3, meaning for every 2 cats, there are 3 dogs. Okay? The question says if there are a total of 50 pets at Petco, what is the percentage of dogs at Petco? So we're looking for a percent. So if I did my part whole, I know that I'm looking for what percent, notice how I added a percent, that's new, percent are dogs. Alright? So, there's a few ways you can solve this. You don't even need to use 50 dogs at Petco, but I'll use that, and I'll also show you without using that. Okay? So in this question, it says that we need to find the whole. Yes, I know you're tempted to say 50, but there's actually another whole. If I look at my given ratio here, I'm given a whole of 5. I got that by adding 2 and 3. So 2 cats plus 3 dogs is 5 pets total. This is out of my small little ratio, okay? So I'm going to say 5 pets. All right? Now I'm given the part, okay? Because it asks, or actually tells us the part. We want it to match dogs. So what number matches dogs? That would be 3. So that means 3 pets are dogs. Since our parts match, I can go ahead and set up a percent proportion. Okay, I'm going to put my part over whole, a percent out of, well, actually, let's do this. We're going to do a 2-step, meaning I'll set up my proportion where you have 3 dogs out of 5 pets total. And now I also know that I have 50 pets total. Okay, I want to figure out how many dogs are out of 50. And then I can figure out the percent of dogs out of 100%. So if I went from 5 to 50, I'd multiply by 10. That means I'm going to use the same logic for my numerator because they're equivalent. they're equal. So 3 times 10 is 30. This means that there are 30 dogs out of 50 total pets. Now I can figure out the percent. How did I get from 50 to 100? I can multiply by 2. If I use that same thought process for the numerator, I would get 60%, meaning that there are 60% of dogs out of the total 50 pets. If you did not want to solve it like that, because I like simplicity, I would have set it up like this. So this is another way you guys can solve, okay? You can take your ratio. The key is, where we're getting confused, is right here. So if you guys can figure out your total pets from your given ratio, you'll be fine. So I'm going to set this part. So I have 3 total dogs, part over whole, out of 5 total pets. I'm going to set this equal to 100%. Because we're still scaling, we're still setting it equal. It should still be 60%. So let's check to see if we were right. We don't even need this middle section right here. So from 5 to 100, we're going to multiply by 20. Because 5 times 20 gives you 100. If I use the same thought process for my numerator, 3 times 20, it actually gives me the same thing. I still get 60% are dogs. Okay? So again, it's a little complicated, but the more practice you do, you'll be fine. Okay? So let's move on to question 4. Question 4 says, last night LeBron didn't make 12 free throws. Okay? If his free throw percentage was 75%, how many free throws were attempted? So I'm going to go ahead and start with the part whole. And we're going to deconstruct the word problem. So I told you the first part is you need to see what it's asking for. What is it asking you to solve for? Because you can't just make up what it's solving for. The question says, how many free throws were attempted? Your key word is attempted. If you only attempt 10 free throws, that means you only took 10 shots in all, right? So how many free throws attempted is what we're solving for, and that is our whole. So X is the amount of free throws attempted. Okay? Now we're going to deconstruct the other 2 pieces. The first sentence says, last night LeBron didn't make 12 free throws. So I know that's a part because it's 12 and it's not our whole. So I'm going to say 12 is what he didn't make. So he didn't make those shots. I'll be specific. The second piece says, if his free throw percentage was 75%, this means free throw percentage. That means that's the amount of shots he made. That's the percent of the shots he made. So 75% are the free throws he did make. He did make those shots. Now we have to